Okay, in this video we're doing Calc BC Problem Set number 11. The playlist and the problems are in the description below. Let's take a look. Evaluate the limit as n approaches infinity. The sum from k equals 1 to n of the quantity 2k over n times 2 to the 2k over n times 2 over n. Okay, so the first thing I notice is when I see the limit as n approaches infinity of a summation, so in BC this is a little more complicated than AB, or at least there are more options. But if you see the limit as n approaches infinity of the sum from 1 to n, you should immediately be thinking this is probably a definite integral. So if it's a definite integral, we have to figure out what the function is, what x sub k is, and what delta x is. Delta x is usually the first thing I look for. So here you can see there's just this like 2 over n, right? We're doing rectangles, basically it's base times height. The base in this case is going to be 2 over n, so that's going to be our delta x. So delta x is 2 over n. Now we have to go searching for x sub k. Well, x sub k is going to be the thing that we're plugging in. It's the thing that involves k, obviously. So I see this 2k over n. It actually shows up twice. It's also here. So I think that x sub k is going to be 2k over n. Using x sub k, we're going to find the bounds of our definite integral. And the way you do that is you let k equal 0 and you let k equal n, and you just see what x sub k gives you. So when k is 0, we're going to get 2 times 0 over n, which is just 0. And then when k is equal to n, we get 2n over n, which is just 2. So our bounds for our integral are going to be 0 to 2. Now the question becomes, what is the function, right? It's base times height. The base is delta x. So the height is the thing we're plugging x sub k into, or rather what we get when we plug x sub k. The function is what we plug x sub k into. So you can see it's x sub k times 2 to the x sub k, so our function f of x is just going to be x times 2 to the x. Being able to rewrite these sorts of things as definite integrals is definitely a skill that you need. So our integral is going to become the integral from 0 to 2 of x times 2 to the x dx. This, unfortunately, is integration by parts, and I don't know why I felt compelled to do this. I'm going to make u equal x and dv equal 2 to the x dx, which means that du is just dx. And then v, remember, so the derivative of 2 to the x is 2 to the x natural log of 2. So the antiderivative is going to be 1 over natural log of 2 times 2 to the x. All right, so our integral, which I'm going to rename just like I is going to be equal to uv, which is 1 over the natural log of 2 x 2 to the x. And that's going from 0 to 2. And then minus the integral of v du, so 1 over natural log of 2, 2 to the x dx. So the first part we can just evaluate with the fundamental theorem. When you plug in 2, you get 2 times 2 squared over natural log of 2. When you plug in 0, it just zeroes out because you have x times, so that's gone. We have to integrate this, so the 1 over natural log of 2 is just like a constant multiple. Ignore it for a second. Integrate 2 to the x, you get 1 over natural log of 2, 2 to the x. So there's actually 2 of these 1 over natural log of 2. So we get 1 over natural log of 2 squared, 2 to the x, again from 0 to 2. So the first part here is just 8 over natural log of 2. Here, we're going to plug in 2, which gives us 2 squared, and then plug in 0, which gives us 2 to the 0, which is 1, and then over natural log of 2 squared. So I'm going to say my final answer, 8 over natural log of 2 minus 3 over natural log of 2 squared. There you go. All right, let's take a look at the next part. So f of x is the sum from 0 to infinity of the quantity 2x minus 3 to the n over 4 to the n plus 1. All right, we want to find the interval of convergence. I'm going to first rewrite this a very tiny bit. I don't like that n plus 1, basically. So I'm going to make this go from 0. I'm going to take 1/4 out, right? I'm rewriting 4 to the n plus 1 as 4 to the n times 4 to the first. And then 4 to the first in the denominator is 1/4 overall. So we have this. Now it's pretty clear to me that this is geometric. And a geometric will converge for the absolute value of r. R is 2x minus 3 over 4. So the thing to the nth power. So 2x minus 3 over 4. The absolute value of that is less than 1. So geometric will always converge for the absolute value of r less than 1. Now we got to solve this. So I'm going to multiply both sides by 4. Get absolute value of 2x minus 3 is less than 4. What I do is I'm going to take out the coefficient of x. So the coefficient of x, I'm going to factor that out of everything in the absolute value and then factor it out of the absolute value. So I get 2 absolute value of x minus 3 halves, and divide both sides by 2 to get absolute value of x minus 3 halves is less than 2. Now what I'm going to do is I'm going to draw a number line, and I'm going to put 3 halves, and then I can go 2 in either direction. I now know the radius is definitely 2. So if I go 2 to the right, I get 7 halves. If I go 2 to the left, I get -1/2. So we will converge everywhere inside that interval, and geometric never converges at the endpoints. So our interval of convergence is going to be -1/2 to 7 halves. That's the whole thing. All right, let's look at the next part. For each of f of 1 and f of 4, either find the value or explain why it doesn't exist. All right, so we did a little bit of work, right? We already rewrote this thing to look like this. This is geometric. The sum of a geometric is the first term over 1 minus the ratio. The first term is found by taking that bottom index, in this case n equals 0, and just subbing it in. So if I sub in n equals 0, I get 1/4 times stuff to the 0. So I just get 1/4. So the first term is 1/4 over 1 minus, and then the ratio is the thing to the n, so 2x minus 3 over 4. You can clean this up. I'm going to get a common denominator in the denominator, which gives me like 4 minus the quantity 2x minus 3 all over 4. But then it's a complex fraction, so I'm going to like keep change turn is how I do that. Multiply by the reciprocal. You get 4 times 1/4 is 1, and then you have your 4 minus quantity 2x minus 3. This cleans up to 1 over 7 minus 2x, and don't forget our interval of convergence is -1/2 to 7 halves, which is super important in this problem because we need to check and make sure the number that we're trying to sub in is in the interval. In this case, 1 is in the interval, so we definitely know that f of 1 is just going to be the result of plugging 1 into this function. It's 1 over 7 minus 2, which is just 1/5. On the other hand, when we're asked to find f of 4, we know that f of 4 just straight up does not exist. And the reason that we know that it does not exist is that 4 is not in the interval of convergence, so you can't actually find f of 4. All right, let's take a look at, there's 2 more parts. So next part, we want to find f prime of 0. So given something that looks like the original f of x, finding f prime of 0 would be annoying. But given that we rewrote it to look like 1 over 7 minus 2x, and 0 is in the interval of convergence, it makes sense to just, I'm going to rewrite this in my mind and use the chain rule. So I'm thinking 7 minus 2x to the negative first. So that's going to be -1 quantity 7 minus 2x to the negative second times the derivative of 7 minus 2x, which is -2. Then just plug in 0. When you plug in 0, you're going to get negative and -2 is +2. And then 7 squared over 7 squared. Well, 7 to the negative second. So 2 over 49 is the value of f prime of 0. Don't be intimidated by that. You get asked these kinds of questions a lot. In fact, the next question is sort of similar, right? So like given the original, this looks very hard. And if you just try to put like the summation in there, it kind of gets a little confusing. But if instead you say what function is this equivalent to on its interval of convergence, which we know is 1 over 7 minus 2x, this is actually a pretty straightforward problem. We're just doing the integral from 0 to 1 of 1 over 7 minus 2x. Okay, so by the chain rule, or if you try to do U substitution, there should be a -2 in the numerator by the chain rule. There's not, so we put it there, and then we balance it with -1/2. Now it's perfect, so it's the natural log of the absolute value of 7 minus 2x. We're going from 0 to 1. I find the absolute value, I mean, you always have to put the absolute value, but it's really important with definite integrals because sometimes if you don't have it, you try to take the natural log of a negative and you're like, oh no, this doesn't work. That's when you realize like, oh, I'm supposed to put absolute value there. That's one of the main places that they're like super important. So just -1/2, natural log of, when you plug in 1, you get 5. When you plug in 0, you get 7. So we could just leave our answer like this, which would be totally fine. Subtraction between natural logs becomes division within. So we could also say -1/2 natural log of 5 over 7. You can also do a weird thing where you take the negative from -1/2 and you say that's -1, and then coefficients become exponents. So you have 1/2 natural log of the quantity 5/7 to the negative first, which is 7/5. So you could also say 1/2 natural log of 7/5. It's like there's no telling what an answer will end up looking like on multiple choice when there's properties of logs involved. So make sure you're familiar with the properties of logs. All right, that's the entire problem set. I hope this was helpful, and good luck.